Recently, new memory technologies known as NVM have been released that offer both durability and byte addressability. Using NVM eliminates the need to serialize data out to secondary storage. However, due to the presence of DRAM in volatile caches, using NVM is tricky. Currently, the user must both explicitly identify which objects should be placed in NVM and add instructions to ensure writes are propagated. We believe this is too much work. To simplify this process, we have created AutoPersist, a new Java NVM framework which leverages the runtime to do much of the work. In AutoPersist, the runtime dynamically detects which objects must be stored in NVM and ensures object updates are persistent. We find AutoPersist is easier to use and also outperforms current Java NVM offerings. To find out more about AutoPersist, please come to my talk.
Mesh is a plug-in replacement for malloc that, for the first time, eliminates fragmentation in unmanaged languages like C and C++. We say that two pages are meshable if they contain objects from the same size class and live objects on each page don't overlap. Mesh copies all live objects onto a single physical page, remapping one of the virtual pages to point at the physical page and relinquishing the other physical page to the OS. Mesh overcomes two key technical challenges. First, Mesh uses a randomized allocation strategy that scatters objects within each virtual page, making it provably exceedingly unlikely that we'll end up with low occupancy pages that are unable to be meshed. Second, Mesh incorporates an efficient randomized algorithm that's guaranteed with high probability to quickly find candidate pages to mesh. In practice, Mesh is able to significantly reduce memory consumption in programs like Firefox and Redis. Come to our talk on Monday at 4:20 to hear more.
Integrating non-volatile memory and DRAM into a hybrid memory system is a promising way to satisfy their memory capacity and energy consumption requests. The key challenge to use this new memory architecture is how to place data appropriately. A common approach to manage hybrid memory is to let the OS monitor and migrate frequently accessed pages from NVM to DRAM. However, this approach is not suitable for big data applications written in major languages. The garbage collection frequently runs to compact live data, which can destroy the data layout determined by the OS. Big data systems can perform application-level memory management at coarse granularity. However, the runtime system would not see these semantics except for a bunch of Java objects. We developed Panzer, who were able to reduce Spark's energy consumption by more than 40% at only a 4% performance overhead.